So today, we're going to do 6.2 properties of a power series. Okay, so I brought the screenshot here already. Combining power series. So we do combining with addition and subtraction. So two series, power series, we combine them. Okay, then they must have, look, this series converges to this function. So f of x, and this converges already make a mistake. This series converges to g of x. All right, then they must have a common interval I, right? So that is that. Okay, then they say that if they add that, since they converge respectively f and g, so they can converge f plus g on the common interval. Okay, all right, this one like a composite function. Wait a minute. So this one, we have a b equal to real numbers and power series like that. So this is a power series, right? Then this one, they just using b sub b real number x to the m. Now they have converged to this one because they say that this series converges to the f of x earlier, right? So this one converges to that. This one converges to that. All right. Okay. Now this one is a composite function. So look, b x to the m power. This one acts like x to the m power. Can you see that? So this will be right. Then look, we have this series converge to the f of x, right? So this one whole thing converge to the f of x, but x is b to the x to the m, all right? So it's okay, right? But it looks so hard, but it's not when we have example, okay? So let us do this. Let me move on. So we have series, power series, a sub n, x to the n, and interval. Let me just denote, cut everything out, interval convergence. Hi, how are you? -1 to 1, okay? And we have a series, b sub n, x to the n, power series, we know that, interval convergence, -2, 2, all right? Now, find the interval of convergence of the series. Okay, the addition. N plus b to n, x to n power. Okay, so look, we're gonna just find the common interval. Means the common interval of convergence, okay? So look, easy. We have number 9. So the series, the second one, this is between -2 to 2 interval convergence, right? So -2 to 2. All right. Then first one, the interval convergence, which is -1 and 1. Then what's the common interval then?
Would it be -1 and 1?
Yes. So -1 and 1 is inside the -2 and 2, right? So yes, common interval of the addition is -1 to 1. Oops. Crazy. Already crazy. Oh. Almost as write down one more time. So infinite -1 to 1. Okay, very good. All right, second one. Let us do this. Find the interval of convergence of the series. Then we have this series, A7, 3n to the x to n. All right, so look, we have a more than x there with n power, right? Okay, then look, we're gonna think the basic power series, right? So what was it? We have a sub x sub n is the basic one, okay? So this will be 1 over 1 minus x, right? Then we know that the absolute value of x is less than 1. So converges, right? So we converges between -1 and +1, yeah. So that is interval of convergence. Okay, all right. So we're gonna make this a form, which is summation n to the 0 to the infinity a sub n, and we have a 3x to the n power, right? Because they have the same n power. All right, now we can see that this will be 1 over 1 minus 3x. Okay, now can you see in this case? You cannot see. Absolute value of 3x is less than 1, right? Then we know that without absolute value -1 to 3x, the 3x between -1 and 1, right? Okay, we want to find x. So we're gonna do divide by 3 both sides, then we get -1 over 3 and x 1. I'm sorry, 1 over 3, 2, right? So this is the interval of convergence. Which is between -1 over 3 to the +3, okay? Okay, now, let us do we do construct power series. So let me see, just to make it shorter, construct a power series. Okay, we have f of x equal to 3x over 1 plus x squared. Okay, so let's take a look. So look, everything is a basic power series, which is this one. Okay. All right, then look, we're gonna say this one is equal to 3x, yeah, and then 1 over, and then we have a subtraction in the denominator, so we're gonna make 1 minus x squared to make positive x squared, right? Now, then look, this will be, look, if we have x, then there will be x to the n power, right? Okay, then look, look. We're gonna say this one. I cannot see what. 3x, then negative x squared. So this whole thing will be x to the n power, right? But then we have a square. Oh yeah, we have a square there. That's correct, right? So let me see, whole thing then, yeah? Because normally we have just x itself. Okay. Then how about this? Huh? All right. Now we're gonna say that this whole thing make the n power. So this will be negative x to the second power to the n power. Okay. All right. Then look. Wait a minute. Hold on 1 second, because the negative sign, right? We get negative x there. Okay, now we're gonna make negative, right? If we have a parenthesis squared, then it's positive. So I don't want that, right? So sorry about that. So we can just say that negative x squared. Oh, parenthesis again. I have a habit. Negative x squared. How about that? Oh, I always have it there, right? Okay, then this will be whole thing to the n power, right? Ooh. X and negative x to square to the n power, right? All right, now note. We can say that negative 1. Yeah, we can say that like that, okay? All right, then we will have, let me write down n start to 0 to infinity. So look, we're gonna say this one will be series from n start to 0 to infinity, 3, negative 1 to the n power, and look, x We multiply, what do you get?
Win.
2n, right? So we get 2n. So we get 2n. All right, but then we have another one, x there, right? So this is, don't forget, we have a 1 there, right? So we have a plus 1 there. Is it okay? So we have basically from the rational function, we found power series here. All right. Okay. How about we have a power series reverse? We're gonna find the rational function, all right? Power series 2 to the n power x to the n. Find rational function. Okay. Easily to see, so this will be n equal to 0 to infinity. So we can say that 2x to the n power, right? But then look, once again, right? The basic power series. We have summation x to the n, which is 1 over 1 minus x, right? So this one whole thing will be there, right? This one whole thing will be there, right? So this will be what? 1 over 1 minus 2x. Done, right? Good. All right, so multiplication of power series. Let me bring the screenshot here. I think I should bring here. Multiplication. Ooh, almost hit the delete. God. Rushing. Okay, so multiplication, we have a series, all right? How do we multiply? We multiply term by term, okay? So here they make a 2 series, we multiply together, then we get another just name, okay? Doesn't mean anything. They're just using C, D, E, right? So don't get confused with the number E, all right? Just the letter, all right? Okay, since we know that from previously, right? From previous, so this series converges to f of x, and this series converges to the g of x. Then we multiply together, we create another series. Then this one converges to the times of f of x, g of x on the common interval, okay? All right, so we multiply. So we have the function 1 over 1 minus x. Then we can express this one, right? 0 to infinity. Then x to the n power. And this one, we know that how to express as a term by term, right? So when n equal to 0, we have 1, right? When n equal to 1, we have x. So this one is like that. Okay, what if we have x squared, right? Then this is the same as the denominator x squared whole thing we put in the x, right? So we have x squared to the n power. Okay, now we will have when x equal to 0, or we can just set it to n, that's fine too. Then when n equal to 0, we have 1. When n equal to 1, we get x squared. When n equal to 2, we get the x to the 4, right? And 6, right? Okay, how to multiply? Just term by term. We know how to multiply a polynomial, right? Well, it's a lot of work. So multiply, okay. Let's multiply. Multiply. Okay. 1 plus x squared plus x to the third. We multiply 1 plus x squared plus x to the fourth power plus x squared. All right. Okay. So 1, we do everything, right? Then we get just this one, this polynomial. Okay, then add, we will do second term with everything here, right? Okay, this will be x plus, please correct me if I make a mistake, x plus x to the third power plus x to the fifth power. So basically 1 increase the power, right? So 7. All right, I did. Then we multiply this one. Okay, nothing special. So then we have, let me do it here. So plus x squared plus x to the fourth power plus basically increase by 2 for the power, right? Okay, what we see, x to the third power, we do that. All right, so this will be, is it green? What's it green? All right, so this will be x to the third power plus x to the fifth power. So basically we add the power over 3. So we will have 7. We will have 9, right? Okay, then let's combining like term. So 1, x2, 2x2, yeah. Two x2, we get the 2x3, we get 2x4, we get 2x to the 6, we get x to the 7, x to the 8, x to the 9, what we see, okay? This is how we multiply, right? Okay. How about the interval of convergence? So this is interval of convergence is, we know that -1 and 1, right? And this one, we have x squared, the absolute value of x squared is less than 1, converges, right? So we have an x squared between -1 to +1. So it's also -1 and 1, right? So multiplication also, because common interval, right? So interval of convergence is between -1, okay? All right. Differentiating and integrating the power series. So let us do that. Let me bring screenshot here again. Cut.
What was the interval? Oh, -1, 1. Okay, I got it.
Okay, so it's a lot, right? But it's not. It's not at all. Just we know how to differentiate, right? Term by term, right? Same as here. We know how to integrate, right? Term by term, right? Same as here too, okay? Only difference, what happened to C, right? So we're gonna find the C, set it up very easily. The set equal to x, set x equal to 0, then we're gonna find the C, all right? So look, let me just go over. We have a power series, okay? Then we extend term by term like this, okay? How do we derivative? We derivative term by term. So first term, which is constant, is 0. Second term, we get constant, right? Because x. Second term, we get x squared, so 2 times C2, right? And then whatever they have. And third term, we drop the power, so 3C sub 3, and then this one, okay? So same stuff, same derivative, right? Term by term. Now, then, if we derivative everything from this one, then we can express the series this way, right? So basically, we drop the power, then n C sub n, and reduce by 1 the power, so n minus 1 there, right? So same as. Okay, now we do antiderivative, right? So we are doing antiderivative of this one. Then antiderivative, then we get the C. The end, right? We have all the time plus C, right? And we do antiderivative, right? Then we make so first of all here x, right? So we make the antiderivative, and then we make the antiderivative, then 1 plus 1, so we get 2, right? Am I correct? Yes, right? Yes. All right, then everything we do, make a series, right? Then basically we are using power law. So we have n+1. Oh, I know I'm confusing this one. So we have a integrate from the original one, right? Then we get the n plus 1, and we do one n over 1, right? Okay, so we do term by term, right? So every time we do integrate, all the time we have make a plus c, right? That's why they have a c there, all right? Okay, let us do this one. Just example of differentiating power series. Okay, so we have the function f over x. All right, we have a 1 over 1 minus x. We know that this is the series x to the n power, right? And we know that this is like this, right? So many times already now. Okay. With the derivative, how do you get derivative?
Oh, derivative of x over n?
We do derivative, then how do you derivative with this one? Okay, so derivative term by term.
Is it n x and then power of n minus 1?
Okay, so we do n equal to 0 to infinity, x to the drop the power n minus 1. Okay, then this will be what? So basically we do different order. We have to derivative term by term first. So we do derivative. What do you get this one?
Plus
0 and 1
plus
plus 2x.
2x.
Yeah. Okay.
3x squared.
3x squared, right? Yeah. Then we realize that, oops. We realize that this term by term, look, 1, 2, 3, 4, right? So we get the n, then the power reduced by 1, right? Yeah, because the number coefficient is a 3, and then the power is reduced by 1 by the coefficient about the n. Can you see that? Okay. Now, how we get this one? If we derivative 1 over 1 minus x. Do you agree this one? You already.
To be 1.
Oh, then square,
Yeah.
and then we general plus, right? Make sense?
Mm-hmm.
Yes, good. Yeah, but we did a little bit different order. Yeah, book said that, oh, we have f prime of x, which is g of x. Then 1 start 1 over 1 minus x to the quantity squared. And then we're gonna have derivative of this one. Okay, then this will be same as the sum of that series, right? X to the n power. Okay, so when n starts to 0 to infinity. Okay, then we do derivative about this. Then we have 1 plus x squared. Okay, then 0 plus 1 plus 0 plus 1 and then 2x. Yeah, plus 3x to the second power. Then da-da-da, we can create the power series, which is 0 to infinity and x to the n minus 1. But we know everything already. That's why. This one is too easy, right? Okay. All right. How about integrating, right? So this will be last one. Integrating. Find a power series by integrating the power series for f prime and oh, no n. No n, only the power series. Okay, so we have inverse function of trig, which is arctangent. Okay, so what is the derivative of this one? Do you know that?
It's 1 over
Uh,
plus x
minus cosinus x to the second.
Okay,
1
later
over
first.
x squared plus 1.
Excellent, yes. So we do derivative, then we get 1 over 1 plus x squared, right? Then we can see this one like a rational function, 1 over 1 minus, I have to be careful, right? So it's a minus x and inside the square, right? I made the mistake earlier. All right, you can see that rational function right there. All right, now what we do, we're gonna find the power series of this one. So this will be, think 1 over 1 minus x, right? That is a series x to the n power. So we will have this one, negative x squared to the n power, right? 0 to infinity. Okay, now when n equal to 0, we get 1. When n equal to 1, we get negative x squared. When n equal to 2, we get the positive x to the 4th power. And negative 6, positive answer, right? All right, now we're gonna integrate this one term by term, because they say so, right? Integrating power series. Okay, this is one of the technique we are finding the power series, Okay, because we don't know anything about information or tangent, right? Okay, now we're gonna make integrate. So we integrate 1 minus x squared plus x to the fourth power dx. All right. So we do integrate. What do you get? Or let us do term by term. We integrate this one. What do you get?
S
Good. We do second term integrate. What do you get?
1/3 S3 power.
Good. We do integrate the fourth power. What do you get?
X to the
1/5
fifth over
S5
5.
power.
Very good. We do integrate sixth power. What do you get?
S7 power over 7.
Very good. Okay. So and so, right? Now, how do we arrange the power series? Okay. First of all, we're gonna set it up. Oops. Oh, we forgot to see. Plus C, right? Plus C. But then look, we have a dot, dot, dot. There's more. That's why they put on the C in front of the term. Remember earlier, right? So we're gonna make a C in front. Okay, now, how do we find the C? Okay, we're gonna set, always 0 is the easy one, so we set 0 equal to x equal to 0, right? Then we guess everything, right? So C plus 0 minus 0, everything is 0, right? Okay, so this will be we plug in 0, then we get 0, right? Which is C, right? So we can set up C equal to 0, right? Then we will have, this one will be x minus x to the third power over 3 plus x to the fifth power over 5 minus x to the 7 over 7 plus, and so on, okay? Now, it's a series, and start to something else, right? So let us talk about that. And look, how do we express the sign change?
Alternating.
Alternating, so alternating, do you agree like that?
Yes.
Okay, very good. All right, then how about odd number? How do we indicate that? Odd number. In terms of n,
2n minus 1.
2n minus 1 or 2n plus 1 in this case? It's increased by 2, isn't it?
Yeah, 2n plus 1 sounds right.
Yeah, sounds right, right? Okay. Now, what about the, what is called the numerator? Same thing, increased by 2, isn't it? With the other number?
Oh, yeah, same, yeah, x 2n plus 1.
Right? So we cannot express this way. How about n? Start to 0 or 1?
0.
1.
0. I said
Oops.
I said 0 and then my finger is 1. Now I meant to, it's like, oh, 0 later. Okay. 0 to infinity. All right. So if you plug in 1, then 1, 1. So start to this one. Can you realize that? Okay. We want to start to x. 0, this one. Yeah. 0 is here, right? Is it good? Okay, thank you for coming.
Thank you.